All right. Happy Friday. Honors Algebra 2. Going to make a very, very quick video for you to watch this morning about how to solve by graphing. I've got a couple different equations I'm going to show you. The first is going to be x squared plus 9x plus 20, which if you were to factor it would be this x plus 4x plus 5, meaning it should have x-intercepts at -4 and -5. The second one I'm going to show you, and I'm going to turn it off for right now, is going to be x squared minus 5. Okay, so as far as how you can solve by graphing, here's kind of how this works. If you give it an equation, x squared plus 9x plus 20, and you want to see what its zeros are, or you want to see what its solutions are. If you graph it, you look for where the x-intercepts are, and then you just calculate those. Now, we know how to calculate zeros. That's that second into calc, and then choose option 2 for 0. But since I already kind of have an idea what those are, and I already kind of see what those are, I'm just going to hit trace and then type in what I believe the zeros to be. So -4 comma 0, and then we'll try -5, and as we expected, -5 comma 0 works as well, meaning that those are two solutions to your equation. In other words, if you want solutions quick, the only thing you've really got to do, graph your quadratic and find those solutions. Now, there is a downside to this, is that it won't give you exact solutions. Now, in this case, because they're whole numbers, they're exact. But if you were to graph instead of x squared plus 9x plus 20, x squared minus 5, which to solve by square roots, you would add 5 to each side and take the square root. In other words, plus or minus the square root of 5 should be your zeros. Now, this is one that you could probably do by hand fairly quickly. I just want to show you that in graphing it, the problem is going to be that you can't just pick out these zeros, that they're not going to be exact values. Now, you can still calculate those, and this time you'll have to use that 0 option. But if we set a left bound, and then if we were to set a right bound here for our 0, and then guess at that 0, it's going to tell us that the 0 is at approximately 2.24, which is the square root of 5, approximately. Now, if you were to do the same thing on the other side, and again, this graph is symmetrical about the y-axis, in other words, it has an axis symmetry of x equals 0, then you could find this other 0 to be -2.24. Let me just show you again where this is kind of a downside. I'm going to type this in factored form, which obviously if it's in factored form, then logically speaking, you could just go ahead and solve it from here. Let's say you had 2x plus 1 and let's say 3x minus 2, which again, if you were to already have this in factored form, there's really no need to graph it. But in standard form, I mean, if you were to type that out, it would have been, what, 6x squared minus 1x minus 2. So maybe let's graph that one instead. So factored form, we can already see what the 0 should be. Should be -1/2 and +2/3. But let's go ahead and graph this fifth one just to see what it looks like and to show you again that it's not going to give you exact values. Okay, now again, this is when you have to be careful, because if you notice, the zeros look like they're symmetric, and in this case they are not. But if we trace, we're going to calculate a 0. We'll set our left bound, set a right bound, and then we'll guess at this first 0. It's going to tell us that the 0 is at 0.66667, 0. In other words, 2/3, 0. In which case, you could go ahead and use graphing to approximate it if you are familiar with fractions and their decimal approximations. And then obviously for this one, this would be the -1/2 that we saw from factored form. But again, that's going to work if it's fractional. If it's not fractional, like for example, x squared minus 5, where you're taking square roots, unless you've got the square root of 5 or the square root of 12 memorized, then it's probably not going to help you too much. Now the good news is, at least for ACT, this is a good strategy because most everything on the ACT is going to be factorable. So for my juniors and maybe a few of my sophomores thinking about taking ACT this year, solving by graphing is probably going to be the quickest approach. Now, here's the other side to that. You do need to have one side of your equation equal to 0. In other words, if this first one had been x squared plus 9x plus 20 equals 7, you have to move the 7 over before you can graph it. You cannot graph it as x squared plus 9x plus 20 if it's not equal to 0. Okay. That's really all I've got for you guys. I wanted to make sure this video was short and sweet for you. At this point, go ahead and get working on that packet that is given to you. We are going to, on Monday, have a review day, as well as on Tuesday have a review day. Those will be good days for you to get caught up and get ready for test on Wednesday. And then next Friday, we are going to do a little bit of programming and program quadratic formula into our calculator so that we never have to use that by hand again. So, with that, I will leave you. Have a great rest of your Friday, guys, and I will see you back on Monday.